This is the second video from section 4.1. So on the first video we finished problems 3 and 4. Now we're moving on to the next slide, and before we continue we're gonna go over the number E, and is also known as Euler's number. Not Euler, but Euler. I don't know why, that's the pronunciation. And so this person, I believe mathematician, he is the one who discovered it, and I say discover it because it was actually derived by using limits, which is something that it's covered in calculus. Some of you taking 1325, you might go over this. And so if we have a function, I'm just going to explain it briefly, such as this. And I'm just going to use n for a second. Just think of it as x, just my independent variable. And so if we have this function that I have here, 1 plus 1 over n enclosed in parentheses to the power n, and we say that n is going to go to infinity. So the result for this, or the approximation, I guess, it will be around the number 2.71 and then several digits after. And so that number is what it's called E. It does have a lot of significance in mathematics and in science because, as we're going to see in chapter 5, we're going to cover things such as compound interest, and we're going to use something very close to this formula. And here the letter N is going to represent the number of compounding periods. Like if you have a savings account, you can have your interest being compounded once a year, monthly, twice a year, etc. So if you increase the number of compounding periods to infinity, then we get another formula that it's called continuous compounding, and it kind of goes like this. And so we get rid of this part, and so that continuity, that non-stop compounding, it's what changes our formula to E. And so that is just one of the many applications. Also when we model bacteria growth, population growth, we use E sometimes. And well, you guys will see more applications. But right now here, the formula that we have here for this function, think of it as f of x equals 2.71 to the power x. And so that is the graph that you guys see here in blue. And as you can see, compared to the 2 to the power x, which is here in red, and comparing it to the graph of 3 to the power x, which is in green, the graph of e to the power x is like in between, a little bit closer to 3 to the power x because of the number 2.71. It's closer to 3 than it is to 2. So that is how the graph will look. We will keep using E. So don't think of it as a variable, think of it as a set number, and that is just one of the approximations. Your calculator does have a button, and it will look like this, e to the power x. So now let's move on to the next problem, and here there is the number E being used, and this function represents the annual amount of wine in millions of gallons consumed in the United States, and it says that it could be approximated by this function, and this comes from the wineinstitute.org. And so here we're using x equals 50 to correspond to the year 1950. So if we were to find how much wine was consumed in 1990, then if x equals 50 for 1950, then x will equal 90 for the year 1990. So to find the answer to this question, we could substitute the number 90 into the function. So we will have 34e to the power. When you enter this on your calculator, once you press the button E, most calculators will already open the exponent window, and then you will enter your exponent there, 0.029. And then instead of x, I'm going to substitute that, the x that we have here, I'm going to substitute that with the number 90. So you do that and press enter, and the answer should give you approximately 462, and the scale here is going to be in millions of gallons. So 462 millions of gallons. Now the next question is, how much wine was consumed in 2015? So now we said that x equals 90 for the year 1990. So for the year 2000, x will equal 100, right? Because it will be 90 plus 10 is 100. The year 1990 plus 10 years will be the year 2000, so it makes sense. So if we want to find what value of x we should use for the year 2015, we could use the value for x, 150. So that's what we're going to substitute into our function, f of 150, and that will be 34e to the power, you could put this in parentheses, 0.029 times 150, and that should give you the answer. If you have a TI Nspire, you might have to press Control Enter so you can get the approximation, and that would be approximately 955 million gallons. Okay, so now for the part C, it says use a graphing calculator. This is why it's important to have a graphing calculator to determine the first full year in which consumption will exceed 1100 million or 1.1 billion gallons. And so what I did is I used my graphing calculator, the iPad version, but is the iPad version of TI Nspire. So I graphed the two functions here, and I say two because the one in red is actually the horizontal line, same as y equals 1100. Now, why do we do that? Well, because we want to find when f of x is equal to 1100, we want to find what x equals to. And so the idea is that if you graph your first function, the one that we were given here, that would be this graph, and then the 1100 will be this horizontal graph, and it's similar to saying y equals to 1100. So to find the solution, it's like you're creating two equations, and you're saying the right side will equal 1100 and the left side will equal the function that we had been given originally, which was this 0.029 to the power x. So this is what we're doing, but we're going to solve the equation with the graphing calculator. We're going to find this intersection point. Now the answer is already here, but I'm going to show you how you will find it on the calculator. So this is what we are creating with our two graphs, and we're trying to find that intersection point. The x value we already know is going to be 119. We're probably going to round it to 120, and the y value will be 1100. We already know that because that's where we want it to be, at 1100. So if you go to your calculator, and then for example mine, you will press the menu button and then look for something that says analyze the graph or calculate for a TI-84, and right here I'm going to try to find the intersection, and for my lower bound or left bound I'm going to move that line so it's on the left side of my target point, the one with the intersection. Then for my upper bound or right bound, I'm going to move that line so it's on the right side of my target point. And you can see how the number will be here. And so that will be 120 for the value of x. So that year, 120, that okay, and I'm sorry, I'm going to apologize here. I made a huge mistake.